One last question here. What is the domain of this? Well, let's look at the numerator. So again, we know that the numerator issue is square root. The radicand has to be greater than or equal to 0. Solve. And we have that. Subtract 1 from both sides. And we get that my domain for the numerator has to be greater than or equal to -1. Great. Now, what about the denominator? Well, if I look closely, x squared plus 10, this is a quadratic. And we have established that this is just going to be multiply two numbers, add numbers. So the domain of this is domain. I want to do two different things, and I executed none of them. Domain is going to be negative infinity to infinity. So as far as the denominator is concerned, the domain is all real numbers, but we have the issue of this cannot be equal to 0. So now the question becomes, what causes the denominator to be equal to 0? Well, if I subtract 10 from both sides, I get this. But now I started seeing a problem. What number multiplied by itself gives me a negative number? And the answer is, again, remember, the input here has to be a real number. So what real number, when multiplied by itself, gives you a negative number? The answer is no real number does this. Well, okay, what does that mean? Well, there's no solution. No, as a matter of fact, no real number solution to x squared plus 10 equals 0. Well, what does that mean? Well, that means that I don't have to worry. I can enter any number I want, any real number I want, into x squared at 10, and I can be guaranteed that it will not equal 0. So this does not equal 0. Yeah, that's what we're saying. Okay, so in that case, the domain of the denominator was really all reals, and nothing will cause the denominator to be equal to 0, so we don't have to worry about that. So what is the domain of this function? So the domain of x is, we're just going to be restricted by the radical. Just get this right. We can just move on. Starts at -1, includes -1, goes to infinity, and that's the domain of this thing. Okay. Here's another fun definition that we'll see later in the course, but might as well kind of introduce it right now. The 0 of a function is a number, let's call it a, such that f of a equals 0. So the 0 of a function is the number that produces a 0 for the output of a function. That's what the 0 is. Okay. So for example, -1 for this radical is the 0 of this numerator function, because its output will become a 0. Right? If I come back over here and you started wondering, well, geez, why is that important? We'll see later on why it's important. Just kind of putting in your mind right now. Sometimes we do these calculations and we move on, got the answer, move on, but we don't put it all together. So when I do -1 plus 1, that gives me 0. Here I get -1 squared is 1. 1 plus 10. What I have is square root 0, 0 over 11, but the answer is 0. So that number, -1, is a 0 of the function. And again, you might ask the question, why is that important? Zeros give us lots of leeway, information, procedural advantages, and we'll exploit those later in the course.